Hello everyone. I hope everyone is okay. This was the most requested rather topic from the learners. This video will be about trigonometry. I'll be doing trigonometry. Trigonometry. Please guys, just pay attention because trigonometry, guys, is not difficult. It's just a game of numbers. Are you together? If you just learn how to do around with numbers, trigonometry man will be man. Okay. I want us to have this basic knowledge, that in mathematics, a complete number is made up of two things. Are you together? A number is made up of a value. A value can be 1, 2, 3, 4, 16, etc. Are you together? And a sign. That sign is plus or minus. For this number to be complete, it must have these two things, It must have a sign and a value. Now I know that my complete number is -7. It must have a sign and a value. My complete number is +8. It has a sign and a value. My complete number is -3, right? So please keep this logic and apply it to trigonometry, guys. Trigonometry is just a game of numbers. Are you together? However, a number in trigonometry is also made up of two things as well. In trigonometry, a number is made up of two things. A number is made up of a trig ratio and an angle. And please guys, make sure that angle is always between 0 and 90 degrees. We always work with acute angles. Are you together? If you combine a trig ratio and an acute angle, you will get a complete number. For example, if you take sine, or the trig ratios are that we have a sine, cos, and tan. Are you together? And then there are other three trig ratios. Those are sec, cosec, and cot. Are you together? If you don't do if your syllabus does not cover the last three trig ratios, it's fine. You have nothing to lose. You can just ignore whenever I talk about these things. But you have nothing to lose because no one will teach you in university about sec, cosec, and cot. They'll expect you to know it. Okay. If ever I combine a trig ratio and an angle, I will get a number. Even if you punch your precious calculator, take sine. Sine is a trig ratio. 30 degrees is an angle, which is between 0 and 90. You will get a number. If you combine the two, a trig ratio and an angle, you will always get a number, √2/2. If you combine a trig ratio and an angle, you will always get a number. Are you together? So in trigonometry, a number is made up of a trig ratio and an angle, which is always between 0 and 90. Are you together? So we have, sometimes we can be given angles which are greater than 90. And our duty is to make sure that we always reduce those angles. Are you together? Angles in trigonometry are found in this region called the Cartesian plane. The Cartesian plane, right? Whereby you have 0 here, you have 90, 180, 270, and 360. Are you together? Please note that in the first quadrant, angles will be just written as they are. Theta. Are you together? But if you want to reduce angles which are greater than 90 but less than 180, we'll simply say 180 minus theta. And if you want to reduce angles which are in the third quadrant, we'll simply say 180 plus theta. If we want to reduce angles which are in the fourth quadrant, simply say 360 minus theta. Are we together? And please note that, guys, in the first quadrant, all the trig ratios are positive. Are we together? The second quadrant, sine is positive. In the third quadrant, tan is positive. In the fourth quadrant, cos is positive. Are we together? And for those who are doing sec, cosec, and cot, please note that whenever sine is positive, cosec will be positive. Let me write neatly. Whenever sine is positive, cosec will be positive as well. Whenever tan is positive, cot will be positive as well. And whenever cos is positive, where did my C go here? Whenever cos is positive, please note that sec will forever be positive. Are we together? You will later understand why sine goes hand in hand with cosec, tan with cot, cos with sec. You will see that whenever we do the reciprocal identities. Okay. Sometimes, guys, you can be given an angle like this. Maybe a number like sine of 120. Here, so calculator will simply write for you this thing is equal to root 3 over 2. Are you together? However, you are always marked in mathematics whenever you reduce your angles. Are you together? So since 120 is an angle which is between 90 and 180, simply means is an angle in the second quadrant, we can simply say sine of 120 can be written as 180 minus 60 degrees. This thing will be equal to root. Before I go there, if I have a statement like this, 180 minus is just a reduction formula. So whenever I reduce this thing, I need to check 180 minus is in which quadrant. 180 minus is in the second quadrant. Is sine positive or negative? Yes, it is positive. So I'll simply write this thing as sine of 60 degrees. Are you together? And then I know that sine of 60 degrees will be equal to root 3 over 2. Are you together, guys? So it's kind of important for you to know the special angles, but we'll talk about that in a later stage of the video. For now, let's just learn on how to reduce angles, because sometimes you're not given numerical values. Maybe you're given 180 minus theta, 180 plus theta, 90 minus theta, and so on. Are we together? So if ever you have maybe let's say the cos of 180 plus theta, they want us to reduce this, and then our main objective is to have a trig ratio and an angle of theta which is always between 0 and 90. Please remember that I said for you to have a complete number, you must have a trig ratio and an angle of theta, and that angle has to be between 0 and 90 always the time. Né? So our ideal situation in trigonometry is to have something like this: sine theta, not sine of 180 minus theta. We want to have something like this. This is our ideal situation. So what I will do if I have something like this, okay, I will go and check. I have cos of 180 plus theta. I will go to my Cartesian plane and check where can I find 180 plus theta. 180 plus theta is in the third quadrant. In the third quadrant, is cos positive or negative? It's negative. So I'll simply write negative cos theta. Are you together? If I have the sine of 180 minus theta, okay, 180 minus theta is an angle in the second quadrant rather, and in the second quadrant I know that sine is always positive, so whenever I reduce this guy I'll simply have a positive sine theta. I don't need to write a plus sign if I'm writing a positive number. Are you together? I can have something like the cos of let's use a different trig ratio. Maybe now we have a tan of 360 minus theta. Okay, tan of 360 minus theta. The first thing we need to do is to check where can I find 360 minus theta on my 4 quadrants. 360 minus is in the 4th quadrant, and in the 4th quadrant tan is negative, so I'll simply write a negative tan theta. Are you together? For those who are using cosec and sec and cot, it's the same logic, guys. If we have the cot of 180 minus theta, okay, 180 minus theta is in the second quadrant. In the second quadrant, only sine and cosec are positive. Everything else is negative. So my answer will be a negative cot theta. Are we together? So please guys pause the video and reduce these few angles. I have sine of 180 plus theta, number 1. Secondly, I have the cos of 360 minus theta, and then I have the tan of 180 plus theta. I have the sec of 180 plus theta, cosec of 360 minus theta. Then number 6, I have the cot of 180 minus theta. Okay, I did 180 minus theta. Let's say plus now. Please pause the video, guys, and just reduce these things. It should take you a minute maximum. Okay. For the first one, I have sine of 180 plus theta. Are you together? 180 plus theta is an angle in the 3rd quadrant, and in the 3rd quadrant sine is negative, so that means I'll simply have a negative sine theta. Are you together? And then number 2, I have 360 minus theta. 360 minus theta is in the 4th quadrant. In the 4th quadrant, cos is positive, so I'll simply have the cos of theta. Are you together? And then in the 180 plus theta is in the 3rd quadrant. In the 3rd quadrant, tan is positive, so I'll simply have a positive tan of theta. And then 180 plus is in the 3rd quadrant as well, but sec is negative in the 3rd quadrant, so I'll simply have a negative sec theta. And then I'll have cosec 360 minus theta. 360 minus is in the 4th quadrant. In the 4th quadrant, cosec is negative. I'll simply have a negative cosec theta. Are you together? And then I have the cot of 180 plus theta. 180 plus theta is an angle in the 3rd quadrant, and in the 3rd quadrant cot is positive, so I'll simply have the cot of theta. I hope you guys are really understanding this part, because this is how you reduce angles. Are you together? And then sometimes we have something like We have things like the sine of 90 plus theta, we have the cos of theta minus 90, and so forth. Okay, please note, guys, that in trigonometry, if two trig ratios are co-functions of each other, are you together? I'm saying they are co-functions because for you to write cos is basically cosine. Are you together? If you remove the co in front, you'll have sine, but if you add it, you'll have cos. Are you together? So okay, that's not necessarily important for you to know, but I was trying to show you that sine and cos are co-functions of each other. Are you together? And then for those doing the other trig ratios, tan and cot are co-functions of each other. Sec and cosec are just co-functions of each other. All right, together. So if ever I have maybe a sine of 90 plus theta, my answer should be in terms of cos. Are we together? Okay, why is that the case? If the two trig ratios, guys, are co-functions of each other, are we together, and the sum of the angles add up to 90, then that thing will make the two numbers equal. Are we together? In this case, sine and cos are co-functions of each other, and if you add these two angles, we get 90. That means whenever I punch sine theta on my calculator, I should get the same answer as when I punch cos of 60 degrees in my calculator. Are we together? Why? Because sine and cos are co-functions of each other, and the angle between these two numbers, they add up to 90. That means these two numbers are equal. Remember that a number is made up of a trig ratio and an angle. That's why I'm saying that these two numbers are equal. Are you together? But sometimes you're not given numerical values. Sometimes it can be given things that are not special angles, right? Can have sine 40. You should know that sine 40 should be equal to the cos of 50 degrees. Are you together? Sine and cos are co-functions of each other. 40 plus 50 degrees will give us 90. Are you together? So if I have tan of 45 degrees, this thing should be equal to the cot of 45 degrees, because tan and cot are co-functions of each other, and the sum of these angles are 90. Are you together? Mostly you will have co-functions with regards to these two trig ratios, sine and cos. Are you together? But that doesn't mean that you must just ignore the others, né? Okay. Sometimes we'll have something like this, né? 90 plus theta, theta minus 90. We don't have numerical values there. We have theta, the unknown angle. Are you together? Our ideal situation, remember that, guys, is to have sine and theta, cos and theta. That's it. Are you together? We don't want to have the 180s, the 90s minus. Okay, so if ever you have an angle of 90 minus theta, that angle is always in the first quadrant. Are you together? If we have an angle of 90 degrees plus theta, that angle is in the second quadrant, right? Then in the fourth quadrant, you will have 90 minus theta. Are you together? And then in the third quadrant, you will have a negative theta and a negative 90. Are we together, guys? The ones at the bottom, they can be written as, sometimes I don't like using 270, but they can be written as 270, né? This one can be written as 270 plus theta. The other one is 270 minus theta. But most of the times you will find it in terms of the 90s. Okay, so whenever we reduce these things, guys, it's so simple. The same logic applies, but now there's something you need to check first. The same logic applies. Just trying to create room for me to write. Okay, I'm given sine of 90 plus theta. I know that whenever I see 90, my answer should be in terms of cos. Are you together? Excuse me. But before I change this thing to be in terms of cos, I need to check where it is it positive or negative. Are you together? So I have sine of 90 plus theta. I know that 90 plus theta is in the second quadrant. In the second quadrant, sine, the one that I'm trying to change, is positive. So since sine is positive, that means my answer will also be a positive cos of theta. Are you together? I have the cos of theta minus 90. Theta minus 90 is in the second, excuse me. Theta minus 90 is in the fourth quadrant. In the fourth quadrant, cos is positive. So I know that since I had cos here, my answer should be in terms of what? Sine. And I'll have what? Positive sine, because I was changing a positive cos. Sometimes I may have something like maybe the sine of negative theta minus 90. Are you together? I know that negative theta minus 90 is in the third quadrant. In the third quadrant, sine, the one that I'm trying to change into cos, is negative. That means I'll also change to a negative cos of theta. Are you together? If I have cot of theta minus 90, remember that the cofunction for tan is cot, ne? And then for sec is cosec. Whenever I change the cot of 90 minus theta, 90 minus theta is in the fourth quadrant. The cot, the one that I'm trying to change, is negative there. So I'll change it to its negative co-ratio, which is tan theta. Are you together? So please pause the video, guys. The video, and just reduce sine of 90 minus theta, sine of theta plus 90, cos of minus theta minus 90, cos of theta, minus 90, Number 7, I have sec of minus theta minus 90. Number 8 is the sec of theta minus 90. Okay, guys, please pause the video and try to reduce these things. It should take you a minute. Pause the video. Okay, let's do it together, guys. Please mark yourself. Okay, I have sine of 90 minus theta. Once I see 90, I know I need to change I need to change to the co-ratio of sine. Are we together? Okay, but before I do that, I want to know 90 minus theta is in the first quadrant, right? So the sine which I'm supposed to change into cos is positive in the first quadrant. So I'll also change to a positive cos of theta. Are we together? And then I have sine of 90 degrees plus 90 90 degrees plus theta. 90 plus theta is in the second quadrant. Are you together? And in the second quadrant, guys, sine is positive. That means I'll also have a positive cos of theta. Are you together? Okay, now I'll have cos of negative minus theta minus 90. Negative theta and minus 90 are in the third quadrant. In the third quadrant, cos is negative. So that means I'll also change to a negative sine theta. Are you together? And then cos of theta minus 90. Theta minus 90 is in the fourth quadrant. In the fourth quadrant, cos is positive. So this simply means I'll change to a positive sine theta as well. Are you together? And then I have a tan of 90 minus theta. 90 minus theta is in the first quadrant. In the first quadrant, everything is positive. So that means I'll have a positive cot of theta. Remember that tan and cot are co-functions of each other, right? And I have the tan of theta rather. It's theta minus 90 degrees. Theta minus 90 degrees is in the fourth quadrant. In the fourth quadrant, tan is negative. So I'll also change to a negative cot of theta. And then I have sec of negative theta minus 90. Negative theta minus 90 is in the third quadrant. In the third quadrant, sec is negative. So I'll also change to a negative cosec theta. Are you together? And then now I have sec 90 minus theta. 90 minus theta is in the fourth quadrant. In the fourth quadrant, sec is positive. So I'll change to a positive cosec theta. Are you together? But guys, this thing of changing to the co-ratios only happens when you have 90 degrees, which you're supposed to reduce. Are you together? So everything we've done so far, guys, is called angle reduction. Okay? Please don't forget about these. They're very important as well. But these ones, they tend to confuse a lot of people. Make sure that you redo them again. Just pause the video, do them again, and then go back and mark yourself. Are you together? And then I want us to talk about the identities. The identities. We have square identities. Let me write here. We have square identities. Are you together? The most important one is this one. Sine squared theta plus cos squared theta is equal to 1. The other square identities are derived from this one. Are you together? Sine squared theta plus cos squared theta is 1. Are we together? So if ever I want to have sine squared theta, that means I must have 1 minus the cos squared theta. Just take the cos squared to the other side. Are you together? However, whenever you guys now do general solution or prove identities, you will further factorize this thing. This thing is called it's the difference of two squares, right? You are subtracting two squares. What is the square root of 1? Is 1. The square root of cos squared is cos, then minus and plus. Are you together? And then the second identity, the third rather, if you want to have the cos squared of theta, you must have 1 minus the sine squared of theta, which can be further factorized. Right? Whenever you factorize it, you will have 1 minus sine theta, 1 plus sine theta. Are you together? And then the fourth ones are the, let me write them in red, the fourth and fifth. Tan squared theta plus 1 is equal to sec squared theta, and then 1 plus cot squared theta is equal to cosec squared theta. These are the square identities, guys. Right, together. And then we have other identities. They are called reciprocal identities. Reciprocal identities, né? Please note that if ever you have something like cosec of theta, you must write it as 1 over sine theta. If we have sec of theta, you just need to change this to 1 over the cos of theta. And then if you have the cot of theta, you can change it to 1 over tan theta. Right, together. These ones, I'll just write them fast and erase them. They are not important because you would hardly change from sine and then change your thing into cosec of theta. Cos of theta is 1 over sec, then tan of theta is 1 over cot. These ones are not important because always the time you must change the cosec and write it in terms of sine, change the sec and write it in terms of cot, of course, change the cot, write it in terms of tan, or maybe cos over sine. So we won't use these ones. Are you together? I was just showing you that sine and cosec are reciprocals. That's why whenever sine is positive, cosec is positive. Are you together? Tan and cot are reciprocals. That's why whenever tan is positive, cot will be positive. Cos and sec are reciprocal identities. That's why whenever cos is negative, sec should be also positive. So you won't need the green part. That's why I'm erasing it. Okay, these were reciprocal identities, right? These were reciprocal identities. Reciprocal identities together. And then we have quotient identities. There are only two. Quotient identities. Tan theta can be written as sine theta over cos theta. Another one, cos theta. Since you can see that cos is just an inverse of sine, so cot theta rather will be the opposite of tan, right? to be cos theta all over sine theta. Are you together? These are the square identities you might need, reciprocal identities you might need, and the quotient identities you might need. Nah? So basically this, guys, is your basic trigonometry to answer every question you might need. For the grade 12 stuff, I'll do the double angles and compound angles in the next video. Okay. There are steps, guys, of simplifying these things. Né? There are steps of simplifying. Step number 1: whenever you simplify in trigonometry, you'll always simplify. And whenever you prove your identities, you must simplify first. Whenever you find a general solution, you must simplify your equation such that you have one trig ratio equal to a number. So simplifying is very, very important, guys. So these 3 steps are the most crucial steps you'll ever need. All together. So the first one, steps of simplifying. The steps of simplifying. Né? The first thing that you must do, guys, is to always reduce your angles. All together. Remember that angle reduction is what we're doing here, changing the 90 plus into theta, the 180 minuses into theta and stuff. That's angle reduction. Are you together? Then step number 2, it simply says you must check if you can change 2 things into one thing. Nah? Basically this one directs you straight to the square identities. Are you together? Because in square identities, if I can see this thing, this plus this, I can change this into one thing. Are you together? If I can see 1 minus cos, I can change it into sine squared theta. If I can see 1 minus sine squared theta, I can change it to cos squared theta. If I come across tan squared theta plus 1, I can change it to sec squared theta. If I come across 1 plus cot squared theta, I can change it to cosec squared theta. Are we together? And we do that because, guys, we're trying to, like in trigonometry, you'll be given a big expression here, or a big equation. You must simplify it maybe into a single trig ratio or just a number. Altogether, probably might be given 6 terms in one expression. Your duty is to just simplify. Are you together? So thirdly, the third thing you must do, the third step rather, is to change everything into one trig ratio. Just change everything into one trig ratio. If you cannot do that, let me write this latter part in a different color. If you can't do that, guys, just change everything At least change everything into sine and cos. At least change everything into sine and cos. Are you together? And then number 4, just simplify. Are you together? However, guys, the most crucial steps are these ones. Step number 2 and 3. You will keep on repeating until you reach your final destination. You will keep on repeating these things, guys. No matter what. No matter what. You will keep on repeating. Let's find something to simplify together. Let me look for a question here. I can't see my question papers. Let me just formulate something. That's fine. Let's say we must simplify. We are given the sine of 180 minus theta multiplied by tan of 360 minus theta, and also the cos of theta. And then at the bottom we have cos of theta minus 90 degrees multiplied by the sine of 180 plus theta. Okay, maybe they'll say simplify the following without the use of a calculator. The first thing we need to do, guys, to be safe, just build a structure. You can see that at the top you have 3 terms. Just open 3 brackets. It's safer to work with brackets, né? Okay, then all we need to do, guys, the first step says reduce angles. We need to reduce angles, right? Maybe this thing, let's say it says minus sine squared theta. Let me make it interesting so that I can explain some of the things I haven't explained. Sine squared 360 minus theta. Yeah. Okay, the first thing I need to do now is to reduce angles, guys. Are you together? Okay, I have 180 minus theta. 180 minus theta is in the second quadrant, and in the second quadrant I know that sine is positive, so I'll just have a positive sine theta there. Are you together? And then in the tan 360 minus theta, 360 minus is in the fourth quadrant, and in the fourth quadrant tan is negative. I'll simply have a negative tan theta. This one is already reduced. I'll just leave it as it is. Are you together? And then now I have 90. That means I must change to the co-ratio. However, 90 minus is in the fourth quadrant. In the fourth quadrant, the cos that I'm trying to change is positive. So I'll simply write a positive sine theta. Are you together? And then now I have sine 180 plus theta. 180 plus theta is in the third quadrant. In the third quadrant, sine is negative. Are you together? So I'll simply have a sine, negative sine of theta. Okay, for angles that are squared, guys, I don't have to check in which trig ratio they are in. They will be always positive. Are you together? So I'll just simply write sine squared theta. Are you together? Okay. And then now, please note that here everything is multiplied here. Are you together? So I have a right to do this. those two things can be cancelled. Are we together? Okay, and then now the second step says to me, change or check if you can change two things into one. There are no square identities that I can change into one thing. Are you together? Okay, and then I'll skip that step. It says that step says change everything into one trig ratio, and if you cannot do that, just change into sine and cos. Here I cannot change into one trig ratio, and guys, please note that 99% of the times you won't be able to change into one trig ratio, but you can change into sine and cos. Are you together? So whenever you simplify here, now that the sine has been cancelled, I'll be left with negative sine theta all over the cos of theta multiplied by the cos of theta all over negative sine theta minus sine squared theta, right? And please note, guys, that these two, they will cancel one another because they are multiplying. The other one is at the numerator and the other is at the denominator, and then I'll be left with a negative sine theta all over negative sine theta minus sine squared theta. Are you together? Negative sine theta over negative sine theta will give me a positive one because I'm dividing things that are the same, and then I'll have 1 minus sine squared theta. Remember that I said to you guys, I'll keep on repeating the second and third step, right? The second step says that if ever I can change two things into one thing, I must just do so. I know that 1 minus sine squared theta is always equal to cos squared theta. So now I have simplified my huge term into one trig ratio. Are you together? I had how many terms multiplied? 1, 2, 3, 4, 5, 6. I had 6 terms there, but I was able to simplify everything, and I had my final answer as one trigonometric ratio. Does it make sense, guys? Please do this one on your own. Let me think of it fast. Okay, let's say I have the cos of 360. Yeah, I haven't said anything about 360 plus theta. I want to explain it here. Multiplied by the tan of 180 plus theta minus theta all over minus cos squared theta. Okay, please guys, pause the video and just do this one on your own. My handwriting is horrible, but let me say the expression is cos 360 plus theta multiplied by tan 180 plus theta multiplied by sine 180 minus theta all over the sine squared of 360 minus theta plus the sine squared of negative theta minus 90, and then there I'm subtracting cos squared theta. Please pause the video and do this thing on your own, guys, please. Okay. The first thing you need to do, guys, is to just build the structure so that you can prevent making mistakes. But this one is already reduced. Let me just write it like this. Okay. Let's work, guys. I have 360 plus theta. 360 plus theta, guys, is an angle in the first quadrant. Are you together? So I know that in the first quadrant everything is positive. Are you together? So if ever I have 360 plus theta and that theta is always is an acute angle, please, guys, note that that thing is in the first quadrant. Are you together? So I'll simply have a cos of theta, and then now I have a tan of 180 plus theta. Tan of 180 plus theta is in the third quadrant, and in the third quadrant tan is positive, so I'll simply have a positive tan theta. Are you together? Then now I have sine of 180 minus theta. 180 minus theta is in the second quadrant. In the second quadrant, sine is positive. I'll simply have sine theta there. Are you together, guys? And then there at the bottom I have sine squared of 360 minus. I don't care whether in which quadrant is it in. As long as it is squared, I know it will be positive. So I'll simply write sine squared theta. Are you together? I have 90. That means I must change to the co-ratio. Are you together? But since my trig ratio is squared, I don't need to check whether the co-ratio is positive or negative. It will be positive, because if you square any negative number, you get something a positive. Are you together? Please, guys, don't forget that whenever I see sine and 90 in one statement, it simply means I must change into the co-ratio. Are you together? Okay, so now I have the cos of theta multiplying tan is equal to sine theta all over the cos of theta. Are you together? Remember that, guys, I need to change everything into one trig ratio. Or if I can't, I must change everything into sine and cos, right? The sine theta, I'll just keep it as it is. This entire thing is divided by there's an identity, guys, that says sine squared theta plus cos squared theta is equal to 1. So I'll simply write 1 there. Or let me not just divide at all, because I know that the answer will be 1. And then I'll have a negative cos squared theta. Are you together? Please note that, guys, these two will cancel one another, because the other one, yes, they are multiplying. The other one is in the denominator and the other one is in the numerator. Are you together? So I will have sine squared theta minus cos squared theta. Are you together? Because the two signs will multiply one another, because both of them are in the numerator. Are you together? For those who are not in grade 12, your answer should stop here, né? But if you're doing grade 12, you can take out a negative sign here, and then we'll have cos squared theta minus sine squared theta, and this thing will give you a negative cos 2 theta. Are we together? So this is how, guys, you simplify. This is how you simplify your terms in trigonometry. Please, guys, if ever you see, okay, let's do another one with numerical values before we end the video. Okay, sometimes I might have, but that one wants me to teach special angles first. Nah, we'll do it on the other video, guys. It's fine. This video is too long. I hope you guys understand. Please, guys, stay tuned and wait for more videos. I really hope this was a productive video. I'll post other videos and make sure that I finish the trigonometry. Thank you for your time, guys. God bless you.